So we're getting to the end of the kind of individual gas laws where you adjust two variables. In this case, you'd adjust the temperature and see how the pressure varies and keep two variables, in this case, number of moles and volume constant. This is called Gay-Lussac's law. If anybody remembers, remind me to tell you a funny story after this about Gay-Lussac's law, the third year I was teaching. Anyway, if you think about it, as temperature increases, what do you think is going to happen to the gas molecules? They're going to move more slowly, or are they going to move more quickly? If you've been paying attention all along, as the temperature of the gas goes up, the velocity of the gas molecules, or the speed at which they're moving, goes up. And that means that the pressure goes up, because pressure is seen as how often the gas molecules hit the side of the container. So as temperature goes up, pressure goes up. So pressure of a gas is directly proportional to its temperature in Kelvin. Remember, we have to use kelvins for the temperature of gases. Gay-Lussac was the first person to realize or to notice this relationship. Rather than trying to derive this, I'm just going to give you Gay-Lussac's law, which says P1 over T1 is equal to P2 over T2. Okay, simple enough. One problem, and we're done with this. Okay, so we have the pressure in a spray can is 1.5 atmospheres at 25 degrees Celsius. We want to know what is the pressure at 400 degrees Celsius. Okay, so labeling things, because again, you're going to have this whole batch of equations in the first part of your notes, and you don't know what equation to use right now. So you have the pressure in a spray can is how many atmospheres? P1 at a temperature of, well, that should be at T equals, this is T1. What's the pressure? We don't know what P2 is. And here is T2. So you've got P1, T1, P2, T2. That's the equation you want to use. You're looking for P2 right over here. It's kind of nice. It's in the numerator. So we rearrange this equation. We have P1 over T1 times T2 is equal to P2. And then you can just substitute in. So if P1 is, and P1 doesn't have to be atmospheres. I could do it in torr, but let's just do it in atmospheres anyway, because those are the units I gave you. P1 is 1.5 atmospheres. T2 is not 400, but it is 673 Kelvin. Remember, to convert Celsius to Kelvin, we have 273, so that gives me 673 equals T2, and 25 degrees plus 273 equals 298 Kelvin. That's T1. So T2 is 673 Kelvin. T1 is 298 Kelvin. That line was supposed to be horizontal. 1.5 times 673 divided by 298 gives me 3.39 atmospheres. And that's your answer in atmospheres. That's the new pressure. So if you remember to convert your temperatures to Kelvin, you are all set.